Here we're going to look at topic 88, example 3, identify an extraneous solution. The question is, what is the solution of the equation? And then they give us this equation. So the first thing we want to do is factor. Right? You won't always have to factor. Like if you look at try at number 10 on the bottom here, all your denominators are already factored. But for the problem that they give us here, we have a third fraction or a third rational expression that is not factored. Right? So here I need to find factors of 15 that add up to -8. So if you want to use your factor sum chart, feel free to. You're going to need to use some negative numbers. So our factors would be -3 and -5. So we have x minus 3 and x minus 5 would be the factor form of my denominator. Now the next thing we want to do is find a common denominator and write that common denominator out for each rational expression and then make the adjustments to the numerator that we need to make. So looking at all of the terms and all my denominators, my first piece here, I have an x minus 5. So I'm going to put that in my denominator. And then I'm just going to continue along. I see I have an x minus 3. So I'll write that in there. And then if I keep going to the third one, I have another x minus 3, which I've already accounted for. And I have an x minus 5, which I've already accounted for. So my common denominator would be x minus 5 times x minus 3. So I'm just going to write that for each rational expression. Some quick highlighting. All right, next thing we need to do is we need to make adjustments to our numerators. Remember, if you change the denominator anyway, you have to make those same adjustments or same changes to the numerator. So my first rational expression here, the x minus 5 is still there, that didn't change, but the x minus 3 is new. So I need to include that x minus 3 in the numerator. That way I'm not changing the value of anything. I'm not creating a new equation. I'm just changing the way things are set up. Okay, so it's still the same values. In the second rational expression, the x would come down. The x minus 5 is new, so we're going to include that in the numerator. And then on the right side of my equation, the x minus 3, x minus 5, I just swap the order. They're the same, so that 2 just stays. We don't change anything about that. Okay. Now that we have a common denominator, the next thing, and you actually could have done this in the previous step, but I like to do it after I've created the most complicated version of my equation. You want to look at the domain, right? And we'll get into why in a moment, but it has to do with what an extraneous solution is. So in terms of the domain, we're going to have all real numbers except x equals, if you look at this x minus 5 here, x cannot be 5, and here x cannot be 3. So our exceptions would be x equals 3 and 5. Those numbers coming from the appropriately highlighted colors, the orange and the blue. All right, now from here, just a side example. Let's say you have 3 over 4 plus, we'll just say 10 over 4. Don't worry about that, it's not reduced, equals. Now if we were to add these up, we would do 3 plus 10, because they have common denominators, and we would keep the denominator the same. So that's a true expression, right? If you were to get rid of your denominators, you still have a true equation. It works out, it's balanced. And that would be the case for anything. Right? If all the denominators are the same, you really don't need them anymore. So what I'm able to do is I can just pretend that these denominators don't exist. Right? I don't need them. Effectively, what you are doing, and you don't want to write this out because this is where it gets quite complicated in terms of writing, you're multiplying everything by that common denominator and canceling all these out. So like I would do that over here as well. All right, and all these would get crossed out, and you would do it for the middle term. But you don't want to do that. It just gets too messy. Just know that it's kind of this, like, we'll call it invisible math behind the scenes. where if all of the fractions have the same denominator in this equation, we can just get rid of those denominators. We don't need them on the next step. Now from here, we're just going to solve an equation as we normally might solve the equation. So let's distribute x minus 3 plus x squared minus 5x. Let's fix that 2 equals 2. Combine like terms. So I see that I have an x and a negative 5x. So let's combine this and this. I'm also going to rewrite them in standard form. So I have x squared minus 4x minus 3 equals 2. Now, one of the things you want to take note of is if you have a variable to differing degrees or different degrees, so in this case we have a second degree and a first degree, you're almost always, and I'm talking like 99 out of 100 or greater than that, you're pretty much going to have to factor every time. So here I have x squared minus 4x. They're different degrees. If I only had an x squared, I could solve it just as an equation. I wouldn't need to factor. If I had only that 4x, I could just solve it. I would not have to factor. But since I do have multiple degrees, I do need to factor. So I'm just going to move this up here. I'm going to rewrite the same equation. And if we do need to factor, we need to set the equation equal to 0. And to do that, I'm going to move the 2 to the left side. So x squared minus 4x minus 5 would be equal to 0. And now I can factor this. All right, do not try to factor unless it is set equal to 0. So if you have different degrees, you have to factor. And if you are going to factor, you have to have the equation set equal to 0. So now I'm going to find factors of negative 5 that have a sum of negative 4. This one's pretty easy, or actually, you want to be careful with this, but yes, this is pretty easy. Don't get careless. We want a 5 to be negative, so this works out. So we have x plus 1 and x minus 5, and that would be equal to 0. Now the next step we've done hundreds of times, the zero product property. So we're going to say x plus 1 equals 0 and x minus 5 equals 0. Solve each of these. This means x is negative 1 and this one is x is 5. Now we do need to be careful. This is where we're checking for extraneous solutions. Notice that we have x equals negative 1 and x equals 5 as potential solutions. But if we go to our domain, we said that x cannot be equal to 5. That was one of our exceptions. So what's going to happen is this 5 is an extraneous solution. Although it does come out as a potential solution, if you were to plug that 5 back into the original problem, you would get an undefined expression, and then that would cause a bunch of issues because you wouldn't be able to do anything. So the only solution we actually have in this problem would be x is equal to negative 1. The x equals 5 you can label as an extraneous solution, but you don't really want to box it in because it's not going to be a solution to your equation. All right. Just quickly going back through the steps and reviewing, or maybe not so quickly. Your first step is always going to be factor. So make sure you factor first, then find a common denominator. After you have the common denominator, then you're going to look at the domain. Once you have the domain, so you can then eliminate the denominators and then solve the equation. A couple other things. Remember, if you're going to factor, you have to set the equation equal to 0. And you will need to factor if you have varying degrees. So in this case, we had x squared and x to the first. So that tells me that I'm really good chance that I'm going to need to factor this problem. You could potentially use the quadratic formula, but it's way more work than this problem would have been if we used the quadratic formula. So make sure you're factoring. A lot of these will be factor sum methods, so they shouldn't be too complicated. I think that's pretty much it. just be careful going through these problems. You'll follow this system on the right, factoring, finding common denominators. Make sure you're checking domains, eliminating the denominator, solving the equation, and then at the end, just check for extraneous solutions. That's it. Good luck working on the triads. Just follow the same process, and you'll do just fine.